So hello students, I welcome you all to this wonderful series of shortcut tricks. So in this video, I'm going to reveal the tips and tricks to remember the momentum of inertia of all these objects: rod, ring, disc, solid cylinder, solid sphere and hollow sphere. Okay, now let us see the categories. Okay, we will be calculating the momentum of inertia from its geometric axis. Okay, axis perpendicular on the plane and passing through center of mass. We call this as geometric axis. Next, we will be calculating momentum of inertia of the axis perpendicular on the plane and passing through one end. Okay, while I'll be solving, I'll explain you all this in a detailed way. Okay, third criteria I have taken is from diametrical axis, and fourth is tangential axis in a plane. Alright, so let us come to the first object. What is the first object? Thin rod. How the thin rod looks like? Somewhat like this, right? So we have to calculate momentum of inertia which is axis perpendicular on the plane and passing through center of mass. Okay, this is the axis perpendicular to the plane and passing through center of mass. See, in the previous video I have already made you to remember this formula. Okay, I am just brushing up. Next, let us take a thin rod. What they're asking, we have to calculate momentum of inertia from axis perpendicular on the plane and passing through one end. So we have to calculate from one end. From this axis we have to calculate momentum of inertia. For this axis also, in my previous video part 1, I have already given you an amazing shortcut trick to remember. Okay, so if you want to watch that video again, I'll provide the link for that video in the description box. Okay, do check that video. And there'll be no momentum of inertia for these cases in the case of ring. But wait, if you want, I'll just give you another case. Let us take this rod. Suppose if they ask you to calculate moment of inertia from this axis, what is the speciality of this axis? This axis is not passing from center nor even from end. Okay, this is passing from middle. So moment of inertia, if you want to can remember, this is not so important. 7 ml square by 48. This is the momentum of inertia of this axis. All right. So next, let us come to the thin ring. Okay, thin ring. Imagine this is a thin ring. We have to calculate moment of inertia from geometrical axis. I have already explained in the previous video. Very simple, just mr square. Next, axis perpendicular, okay, and passing through one end. This axis I'll just take it in a dotted manner. Now from one end we have to calculate. Okay, from this axis we have to calculate momentum of inertia. Now just look at these two axes. What can you conclude? How these axes are arranged? Parallel or perpendicular? Obviously parallel, right? So here comes the shortcut trick. Now I'll be telling you the shortcut trick. This case is parallel axis theorem. We have to apply parallel axis theorem. So the shortcut trick for parallel axis theorem is parallel axis theorem. So whenever you feel to apply parallel axis theorem, just do one thing: add mr square. Alright, add mr square. And when you feel to apply perpendicular axis theorem, just do simple trick: divide by 2. Alright, so these are the most important tricks while calculating momentum of inertia from parallel axis theorem and perpendicular axis theorem. And let me tell you one thing, don't apply this tricks for all the objects. See why? Because in this formula you can see mr square. Okay, whenever you see spherical object, then only you can apply this. You can't apply this for thin rod because in this expression we have ml square, right? Okay, now let's move on. See, so as you can see, this is here we can apply parallel axis theorem. So for parallel axis theorem we have to add 1 mr square. Okay, now what it will become? 2 mr square. Next case, let us take a ring. Okay, now this is a geometrical axis. He is asking diametrical axis. So this is the diametrical axis. This is a diametrical axis. Okay, for this, in this case, what we have to do is just observe how these two axes, these two axes are perpendicular to each other. So we have to divide by 2 in case of perpendicular axis theorem. So mr square by 2. So this we have to divide with 2. Next, the last case is tangential axis. Okay, tangential axis. This is the diametrical axis. I am drawing this in a dotted manner. So this is a tangential axis. Now observe these two axes, how they are. We can conclude that they are parallel to each other. So we have to add one mr square. For which we have to add mr square? For this expression we have to add mr square. So mr square by 2, if you add one again mr square, it will become 3 by 2 mr square. Alright, okay. Next, let us come to the disk. Imagine this is a disk. We have to calculate momentum of inertia from geometrical axis. This is a geometrical axis. I have already told momentum of inertia of disk from geometrical axis is mr square by 2. Alright, next, momentum of inertia of the disk perpendicular on the plane and passing through one end. Let us take this end. Okay, now how these two axes are lying? These two axes are lying parallel to each other. Now what we have to do parallel to each other means we have to add one mr square. Now what the expression will become? 3 by 2 mr square. For mr square by 2, if you add 1 mr square, it will become 3 by 2 mr square. Next, momentum of inertia from one of its diametrical axis. Now these two axes are perpendicular to each other, so we have to divide this by 2. Final expression will be mr square by 4. In a simple way, you can understand. Okay, just don't stress much. The last case, this is a disk. This is also a disk. Now I'll draw this diametrical axis in a dotted way. Next, tangent. This is a tangent. So this how these two axes are lying parallel to each other. Perpendicular, parallel to each other. So what we have to do? We have to add mr square to this expression. Finally, what we will be getting? 5 by 4 mr square. And next, we have a solid cylinder. This is a solid cylinder. See, in solid cylinder, from geometrical axis we have to calculate. This is a geometrical axis and its momentum of inertia mr square by 2. Already I have explained. And now in the case of solid cylinder, we have a special case. Okay, we don't have all these cases, but we have another special case. See, suppose if the axis is passing from this geometrical axis, even this is also geometrical axis, even this is also geometrical axis. What is the difference? See, whenever the axis is passing in this manner, it is parallel to the plane. It is parallel to the plane of the cylinder. But in this case, it is perpendicular to the plane of the cylinder. So in this special case, we have a special formula for momentum of inertia. This is mr square by 4 plus ml square by 12. You have to remember this. It's very important and it's very interesting also. Okay, this is the only object which has this type of formula. Remaining all the objects in all the cases, general formula. Alright, next we have solid sphere. Solid sphere, same, from center of geometrical axis. Okay, what is the momentum of inertia? I have already told in the last video. I have given you an amazing trick to remember this all basic formulas. Alright, next we have axis passing from one end. Now how these two axes are being arranged in a parallel manner. So for parallel, what we have to do? We have to add 1 mr square to this expression. Finally, we will be getting 7 by 5 mr square. In this case, we don't have these cases. in this object. Next we have hollow sphere, the last object. Hollow sphere, the same setup. Momentum of inertia from geometrical axis, I have already explained, 2 by 3 mr square. Okay, next finally we will be having this setup. We have to calculate momentum of inertia from one of its end. Alright, so if you look at this two setup, what you can observe? Parallel axis theorem. We have to apply parallel axis theorem. So for parallel axis theorem, we just have to add 1 mr square to the basic expression. So we will be getting 5 by 3 mr square. Alright guys, so in this way we can calculate the momentum of inertia from its geometrical axis, axis perpendicular on the plane and passing through one end, so diametrical axis as well as tangential axis to all these objects. Alright, so if you want, you can take a screenshot of this. Okay, I'll provide a link or a PDF for this sheet. Alright, so thanks for watching. Have a good day.